Welcome. My name remains Thank God. Let us look at this question and solve it. What is the pH of a buffer prepared by mixing 0.1 mole acetic acid and 0.25 mole acetate? pK of acetic acid is 4.76. Problem of buffer, or to find the pH of this buffer that is prepared by mixing 0.1 acetic acid and 0.25 mole acetate. There is a formula we must use whenever there is a problem like this, and it is called Henderson-Heisenberg equation. That is the equation Henderson-Hasselbalch equation. Now, this formula is generated from acetic acid, let's say acetic acid dissociating into hydrogen ion and acetate ion. This acetic acid, when it dissociates, it forms or it dissociates into hydrogen ion and acetate ion. Therefore, the dissociation constant, the Ka, dissociation constant, acid dissociation constant of this acid will now become Ka, acid dissociation constant will now become the concentration of this product, this hydrogen ion, and the concentration of this acetate ion all over the main acetic acid. That is to say, acid dissociation constant will now be equal to hydrogen ion concentration. To express hydrogen ion concentration, we use long bracket like this to represent concentration. And acetate ion concentration all over the acid itself, the concentration of that acid. So this becomes the expression for Ka. Now, if we make hydrogen ion subject of the formula, this equation will become hydrogen ion. Remember, if we are making the subject of the formula, remember there is, you can have a cross multiplication here. Cross multiplication in this case means Ka and this goes one side of the equation, while this goes one side of the equation. So if you are making this side of the equation, any of the species from this side of the equation, this other side will become the numerator. Now we are making hydrogen ion subject of the formula. So this other side, everything this side, this line, becomes the numerator of the equation. So we have Ka, concentration of acetic acid all over what we have here. All over this COO minus concentration. Yes. Now the next step is taking the negative logarithm of each of these. To this hydrogen ion, you put negative log Ka, negative log, and this acid and all over acetate, you take negative log of it. It now becomes negative log of hydrogen ion concentration is equal to, then put negative log here, negative log Ka, then put negative log again, minus, that's negative log the whole of this, CH3 COOH concentration all over CH3 COO minus concentration. Now recall that in 1909, A Danish scientist defined pH. pH stands for power of hydrogen as the negative log in base 10 of hydrogen ion concentration. That means he said, mathematically speaking, that pH can be defined as the negative log of hydrogen ion concentration in base 10. So if this is what pH is defined to be, and we have this expression here, this is exactly this. It means that we can replace entire of this with pH. So that is to say, we can say the whole of this will become pH is equal to, we have negative log again, but this time Ka. That means P Ka. The top of this, then minus negative log CH3, the top of this OOH. OOH concentration all over CH3 COO minus concentration. Now, this is what the equation has become. But for simplicity's sake, you can change this sign. We want to change this sign, this minus sign, to a positive sign. So if we are changing this minus sign to positive sign, it now means that we are going to invert whatever thing that is here. Carry this one up. Why this one that is up, we bring it down. The denominator is going to become our numerator, while the numerator will become the denominator for this minus to become positive. It therefore means that we will rewrite this to be pH is equal to pKa plus, we are changing the sign now, log, then we now take this one that is down up. This one that is up comes down. Now let's take the down one now up. Log CH3 COO minus concentration all over concentration of CH3 COOH. So this is the formula. This is the Henderson-Hasselbalch equation that will be used to solve problems that involve preparation of buffer. Now, this also means that this is the acetate, this is the acid, or this is the salt, this is the acid. So this equation can also be written this way: pH is equal to pKa plus log, instead of writing this, you can say log of concentration of salt all over concentration of acid. So this is Henderson-Hasselbalch equation. On our next video, we'll use this equation to solve this problem. For any support, criticism, questions, and encouragement, please put it on the comment section. Hope so that's in the clear.